Okay, so today's topic is going to be angles and the unit circle. So topic is angles and the unit circle. So that's topic. Now the essential question we need to ask is, this is a guiding principle. What is going to be our guide in order to explore angles and unit circle? Our guiding question will be, so you can call it essential question. And the question is, how can we extend the trig ratios to angles greater than 90 to angles greater than 90 degrees. So let me read again. How can we extend the trig ratios to angles greater than 90 degrees? So this is what we shall be exploring today. All right. So I am going to create a simple warm-up, and then the simple warm-up will be in form of it's a visual. So I will draw a visual representation of what I want, and then I will ask you to give me the angles in terms of radians. Okay, so let's start. So I don't want to write warm-up below it, but that's warm-up I'm doing right now. So I'm drawing an angle, a visual, like something like a coordinate plane. This is x-axis. No, this is y-axis. This is x-axis. Of course, you know. This is, of course, you have your values. You have your values on each of these. And I am going to, in each of these ones, I'm going to write the degree, and then I'm going to ask you to write the radian equivalent. So draw the scale like I did, just draw the graphics like I just did. Draw the graphics like I just did. And here at this point, the upper side of it is 0 degree. The lower side of it is 360 degrees. So on this side, this would be 90 degree. This would be 180 degree. This would be, at this point, this is going to be 270 degrees. So now, what I want you to do is tell me the radian equivalent of each of these points. The radian equivalent of 90, the radian equivalent of 180, the radian equivalent of 270, and then the radian equivalent of 360. So that's the warm-up. So take it from there. You have 2 minutes. So basically you are converting 90 degrees, 180 degrees, 270 degrees, and of course 360 degrees. You are converting it to radian. That's all you're doing. 180 is equal to pi radian. This is pi radian right here. How about 90 degrees? It should be in terms of pi as well.
Isn't it 90 equal to pi radian?
90 degrees is equal to pi divided by 2 radian. How about if you get 90 is 90 not equal to 180 divided by 2? Is it not the same thing? So anything that is 180, just divide it by 2, you get 90. Okay, so then how about 270 degrees? How about 270 degrees? We have done this thing here, and I actually gave you an assignment that has to do with converting 270 degrees. So what happened to using 180 degree is equal to pi radian. So then 270 degree is going to be x radian, and cross multiply. So you are going to have 180 multiplied by x equal to 270 multiplied by pi radian. So x will give you 270 divided by 180 radian, pi radian. So then you cross out, you divide by certain number, 27 divided by 9 is 3. So you have 3 pi, and then 18 divided by 9 is 2. So you have 3 pi over 2 radian. So 3 pi over 2 radian. So here is 3 pi over 2 radian. On the other hand, 360 is equal to 2 pi radian. This is actually where we started. Okay, this is where we started. We started at 360 degrees is equal to pi radian. That's where we started this radian conversion. Okay, and if we're talking about 0 degree, 0 degree is also equal to 0 radian. All right. So that was the warm-up, and this is going to introduce us to the topic which I already wrote, and which is angles and the unit circle. And the essential question once again is, somebody help me read, please. Read out loud.
How can we extend the trig ratios to angles greater than 90?
Okay, good. So all along we have been, let me do it beside it. Let me draw it beside it. So all along we have been dealing with trig ratios that has to do with if we have a triangle this way, right triangle, 90 degree. So the rest of these are acute angles. You know, the rest of these are acute angles. And this is where I told you that trig ratio actually started. And the trig ratios we have, basic one of them is the SOHCAHTOA. All right. So now, but not all triangles are right triangles. So some triangles has an obtuse angle on it. So because of some triangles have acute angle on it, so there has to be a way of actually solving problem relating to those type of triangles, you know, and then we still use some aspect of the trig ratios in order to accomplish that. And that's what the whole today's lesson is going to be about.